Everyone already knows LEO satellites bring coverage. In 6G, the real story is, can we treat LEO as just another cell handovers, beamforming, slicing like any other part of the RAN? In 5G, mobility usually means you move, towers stay put, and the network hands you over from one tower to another, like passing a baton in a relay race. With LEO, both you and the tower are moving. It's like running a relay race, where the person you're passing the baton to is also sprinting. So 6G needs predictive mobility, planning handovers based on where satellites will be, not just where they are now. That means predicting line-of-sight windows, Doppler shifts, and handover timing at orbital timescales, not just at cell boundaries. Imagine you're on a stage with two spotlights, one shining from above, one from the front. If both move, someone has to coordinate them so you don't end up in the dark. In 6G, your phone could be under two sets of radio spotlights at once, beams from the ground and beams from space. Multi-layer beam management just means the network can coordinate both layers, so the signal stays locked on you. Think of network slices like insurance policies. A normal 5G slice is one policy. If that fails, you're exposed. In 6G, mission-critical apps get at least two, one slice anchored in the terrestrial network and another slice riding LEO as a backup spine. If the ground path breaks, the space path is still there. A scheduler is basically the traffic controller of the network. It decides who can send data, when, and on which channel. Think of it like someone controlling traffic lights. With LEO added, that traffic controller isn't just looking at roads anymore. It also has to watch planes in the sky. A space-aware scheduler is one that understands both towers and satellites before deciding where each packet goes. If the terrestrial scheduler and the satellite scheduler don't agree on who owns each UE's time, you get oscillations, packets bouncing between ground and space, latency spikes, and mission-critical slices that fail precisely when you need them. All of this sounds powerful, but there's a brutal constraint almost nobody outside R&D talks about. If we get this wrong, LEO stops being a 6G asset and becomes a source of congestion and outage. I'll show you that constraint and who's closest to solving it in a minute. Spectrum is just a set of radio lanes we can drive on. In cities today, those lanes are already crowded with 4G and 5G traffic, like rush hour on a multi-lane highway. Adding LEO is like adding flying cars that also use those lanes as they pass overhead. The interference isn't fixed, it moves. So 6G needs velocity-aware spectrum sharing, radio lanes that can adjust as satellites sweep over cells. If you've ever heard a fast train or car pass by, you've heard Doppler, the pitch shifts as it moves. Wireless signals experience the same kind of shift. Numerology in wireless is just how we choose the rhythm and spacing of the symbols we send, like the tempo in a song. If Doppler and delay change a lot, that tempo needs to be adjustable. LEO pushes those shifts further. So 6G needs adaptive numerology, waveforms that can retune their timing and spacing on the fly. Tracking loops have to anticipate orbital trajectories, not just react to current measurements, or your HARC timing and link reliability fall apart. We don't plan our day based only on the rain we see out the window. We use weather forecasts that predict the next few hours. An AI-native 6G RAN does the same thing for the network. It forecasts which satellites will be overhead, how much traffic will hit each cell, and where interference will spike. LEO turned 6G into a prediction problem as much as a radio problem. Picture your phone being able to look at two Wi-Fi routers at once, one in your room and one on a drone flying overhead, and decide which one is better without draining the battery. For 6G plus LEO, UE antennas have to do something similar. Phased arrays need to steer beams toward towers and satellites, switching between them smoothly, but still fit into a handheld device. Imagine you work for two managers who both give you meeting calendars. If they don't talk to each other, you keep getting double booked and your day becomes chaos. In 6G with LEO, the terrestrial scheduler and the satellite scheduler are like those two managers. If they don't coordinate, your phone keeps getting pulled back and forth between ground and space. The real constraint is multi-domain scheduling coordination, making the network behave like one coherent system, not two competing ones. The winner in this race will be whoever makes LEO feel invisible to the UE. When coordination works, your device just sees a consistent, reliable 6G experience, whether the bits come from a tower or a satellite overhead. In a future episode, I'll show how those AI controllers actually learn the patterns behind all this, like turning raw orbital data and traffic logs into a weather forecast for your 6G network. If you're architecting or building 6G systems, treat Leo not as a bonus link, but as another cell your scheduler must understand. I'll see you in the AI Rant for Leo episode. Subscribe so that you don't miss it.